Welcome to section 1-2 notes, chapter 1, section 2, linear equations. So here in this box on the left in gray has a nice formal definition of what's linear. So I'm going to cut to the bottom here and tell you, here's what we're looking for. No exponents other than 1. So number 1, the first example, I'd like to think you notice that is the slope-intercept form, which is literally for linear equations. So if we don't write exponents on something, understood to be 1, understood to be 1, that's definitely a yes. So really, I think what you want to look for is, other than that, exponents other than 1, and look for something funky happening to the variable. And I'll explain what that means here in a second. So number 2, well, pretty darn obvious. That's not an exponent of 1. So that's actually called quadratic. That's chapter 5 in Algebra 2. But we're in chapter 1, so all you have to worry about for now is writing an n for now. So number 3, here's what I'm talking about. Something funky happening to the variable. So the y, the variable, is inside of a root, inside of a square root. That's kind of weird. It's kind of funky. I'm going to write no, and then I'm going to go back to that and explain why it's not an exponent of 1. Number 4, hey, there's an exponent of 3 and an exponent of 2. That's definitely not linear. So number 5, even though there's fractions, it's still x to the first over 4, y to the first over 6. So that's still going to be a yes. Now, again, what I'm talking about for funky is number 6. Normally, you don't see variables on the bottom of a fraction. So that's going to make that a no. Now, here's why. But again, I'd rather that you just remember, hey, anything funky happening to a variable is likely to be a no. So later on in Algebra 1, we're going to learn that anything on the bottom of a fraction is actually understood to be to the exponent of -1. Well, -1 most definitely is not +1, therefore it's not linear. So back up there to number 3, the fact that you have that y and that -5 inside of a square root, excuse me, and we're also going to learn this later on, way later in the year, roots make fraction exponents. So that's actually understood to be y -5 to the 1/2 power. So again, not equal to an exponent of 1. So I doubt you're going to remember that a square root means 1/2 exponent. I doubt you're going to remember a variable on the bottom means a -1 exponent, but I would say that you're likely to remember something odd happening to a variable. And keep in mind the variable. So if I had just written the square root of 5 in this problem and not the y, it still would have been a yes. So anything crazy happening to the variable is going to be a no for an answer. All right, so there's some yes, no answers. That's some easy stuff. Let's move on to some actual problems. So topic 2 in section 2 is what's called standard form. So we're going to be doing some graphing later in chapter 1, and really this isn't the form that we want for graphing, but I suppose they chose to show you both forms right now rather than wait till later. So here's the form we're looking for. Notice that the x and the y are on the same side. And down here it tells you or gives you some extra tidbits that you got to have. So we're not allowed to have fractions or decimals. So if you look at number 9 and number 10, we're going to have to do something about that. And no negative x means you can't have an x term that's negative, but that's easily fixed, and we'll show you how in number 1. So for starters, the left side is supposed to have the x and the y. And right now the 7y is on the right side. So how do we get that guy over there? Well, he's a positive 7y. I would have to subtract him to get him over there. Now from here on out, I'm going to be shortcutting here. Now here's what I mean. If the 7y was positive on the right side, what did he end up when we moved him to the left side? So in other words, the sign would switch. So rather than showing this work all the time, if you can remember, hey, if I move something from side to side, the sign just changes, it'd be a heck of a lot easier. So I'm going to use that for that positive 1. So standard form is supposed to have the x and y on the same side, which we have. But you're also supposed to have the guy without the variable on the other side. So I'm going to pull this trick. If that guy's understood to be positive 1, if I move him to the other side, he'd be -1. Now, we've accomplished the x and y's on the same side, but unfortunately, it says in the rules over here, right here, the x term cannot be negative, and right now we have -3x. Well, I'm going to change this, and you tell me what I did. Am I allowed to do something to an equation as long as I do it to both sides? And I just did that. I switched the signs on both sides. And that's equivalent of dividing everything by -1 or multiplying everything by -1. But hey, that's an easy fix. So we're allowed to switch the signs in the equation anytime we want, as long as we switch all the signs. So here's the question. Do I have the x and the y on one side? Yes. Do I have any fractions or decimals? No. And did I make sure that the x term is positive? And he is, positive 3x. So watch how easy this is to fix over here. Number 8, I need that 3y over on the same side as the 4x. So if he was positive to start with, he's going to be negative if I move him. So I got the x's and y's on the same side, but I don't want the 10 on the left. I want the 10 on the right. If he was positive to start with and I move him, he's got to be negative. No fractions, no decimals, no negative x term, positive 4x, and I've got standard form. So for number 9, this looks like it's going to be difficult, but it's really not. I think somewhere along the way someone taught you this little trick. If we, again, do the same thing to both sides of the equation, it's legal. So what would happen if I moved that decimal 2 spots? Wouldn't say 0.32 anymore. It would just say 32. Well, if I move that one too, what do you think I have to do to that one? I move them too. And if I move that one too, guess what? I just moved that one too, and it's perfectly legal. So the decimals are gone, and now it's pretty easy to fix. So again, I'd like to see you do one step at a time here. I want 32 on the left side. He was positive. I moved him. Now he's negative. I don't want them all on the same side. I want the x and the y together, which I got. I want the 150 on the other side. Switch a sign, and I got them. Positive x term, no fractions, no decimals. That's called standard form. So you're probably thinking to yourself, well, okay, that wasn't too bad, but number 10 is going to be really hard. Assuming you did chapter A, which if you're in the honors class, you didn't, but I would think that you have learned this somewhere along the way anyway. If we get a problem that has common denominators, we are allowed to erase or just eliminate all the denominators, so there won't be fractions anymore. So the question is, what can I use for a common denominator? Can I make that 2 go up to meet a 15? I cannot. I could make the 5 go up to meet the 15, but I got to have all 3. So what I'm going to do is I'm going to just start doubling the biggest number and seeing if that's going to work or not. So if I double 15, I get 30. Well, can I multiply this 2 by something to get 30? I can. I can multiply them by 15. And if I multiply that guy by 6, I have common denominators. But if you're going to change the bottom of a fraction, somewhere along the way in general math class, they taught you this. So if I go times 6 on the bottom to get my 30, I go 6 on the top, 6x. If I went times 15 on the bottom to get my 30, I got to go times 15 on the top. That would give me 45y. If I went times 2 on the bottom to get 30, I got to go times 2 on the top. I get a 2. So the real convenient aspect of this is once you get common denominators, you get to cross them off. They're gone, no more fractions. Now the reason being that was a 30, and a fraction bar is understood to be a divide. So how do you get rid of a divide by 30? I could have times everything by 30 and all those 30s would cancel. But it's a heck of a lot easier just to remember, hey, if I get common denominators, I get to cross them off. And if I cross them off, let's see what's left. I got that 6y, or 6x, sorry. I got the 45y, and I got a 2. And lo and behold, I have standard form. No fractions, no decimals. The 6x is positive, and I'm done. So keep in mind, if that 6 had been a negative, we could easily fix it just by switching all the signs. And if you're going to miss a standard form problem, it's going to be because you forget that. So this guy right here is the hard one to remember. The x guy cannot be negative, but easily fixed. All right, that's part 1. So stay tuned for part 2. Thanks for watching.